You all are welcome back to KT Physics, and I want to use this medium to appreciate the people that subscribe and like my channel. And I will still advise you to share the video so that some of your friends that don't have access to it can have access to the video. So now, here before me, we're going to be talking about vector and scalar quantity. And these are quantities that are under the classification of physical quantities. We are done with fundamental, we are done with derived, we have actually even touched part of what? Prefixes. So we are going to into what? Vector and scalar quantity. And I'll be very fast about this video. Now, when you talk about vector quantity, as you all know, is what? Vector quantity. Quantities are what? Quantities with what? Magnitude plus what? Direction. Why scalar quantities are quantities with what? Magnitude plus no direction. So when you talk about quantities with magnitude and direction, you talk about vector quantities. And when you talk about quantities with what? Magnitude but no direction, we talk about scalar quantities. And examples of scalar quantities, examples of scalar quantities are all fundamental quantities. All fundamental quantities are example of what? Scalar quantities. And what are the fundamental quantities we have? We have METAL, square. Where this is what? Your mass. This is what? Electric current. This is what? Your time. And what? Temperature. This stands as what? Amount of substance. This stands for what? Length. In terms of distance. And also we have what? Luminous intensity. All these are fundamental quantity. All these are fundamental quantities, and they are all examples of what? Scalar quantities. Now, and another thing you need to understand there is that what? Vector quantities are quantities with what? Magnitude and direction. While scalar quantities are what? Quantities with what? Magnitude but no direction. And these are all examples of what? Fundamental quantities. Now, another way you can actually identify vector and scalar quantities. How to identify? Identify. How to identify scalar and vector quantities. Now, I want you all to take what? Any vector quantity. Take vector quantity as negative. Why scalar quantity as what? As positive. So let us see how we can actually resolve this. So if we have some derived quantity given to you, like example, speed. Speed is what? Distance over time. And distance in this sense is what? Is a scalar quantity. It has no direction, so you put it as what? Plus. And time is a what? A one of what? One of our fundamental quantity, which falls under scalar quantity. You take it as what? Plus. Plus divided by plus is what? Plus. So therefore, this speed here is a what? A scalar quantity. Are you getting it now? Let us look at velocity. Over time. Now, for velocity, displacement is what? A distance with direction. So it's a vector quantity. We put it there. Divided by what? Time. Which falls under what? Fundamental quantity. And which are what? Scalar quantities. So you have it as what? Plus. Minus divided by what? Plus is what? Minus. Which is what? A vector quantity. We can add force. Force is what? Mass times what? Acceleration. So what do you have here? Your mass is what? Your mass falls under fundamental quantity, which is what? Your mass is what? Your mass falls under fundamental quantity, which is what? A scalar quantity. You have it as what? Plus. Your acceleration is what? A vector quantity. If we resolve that, acceleration is velocity over time, which velocity is what? Negative divided by time, positive. So acceleration is what? Minus divided by positive is what? Negative. So we have it as what? Negative. Plus times minus is what? Minus. So therefore your force becomes what? Your force becomes what? A vector quantity. You can use this to solve, but you need to note these arithmetic values. Note. Minus times minus is plus. Minus times plus is minus. Plus times plus is what? Plus. Minus divided by minus is plus. Minus divided by plus is minus, and the likes. So if you can have this in your mind, you can solve for what? These values. So you can say that what? Density. Let us look at density. Density is mass over volume. So what is mass? Mass falls under fundamental quantity. You have it as what? Plus. So we have volume. Length times length also falls under fundamental quantity, which is length cube. We have it as what? Plus. Plus divided by plus is what? Plus. So density is what? A scalar quantity. So you can use it to solve every other quantity. So I want you all to type in the comment section questions in order for us to what? Solve with you. As you can see, this is a very simple way of identifying vector quantity and scalar quantity. See you in the next class. Thank you.